Today's date, 3/5, March 5th, 3/5/18, right? So, polynomial. What did we say about a polynomial? Okay, we said that it has many terms and all exponents are whole numbers. Okay, a polynomial. Poly means many. I mean, it's kind of a Latin word for many. But it has to have whole number exponents. It's got to have like either x squared or x cubed or x to the fourth, but it can't have x to a fraction. It can't have x to a decimal. It's got to have whole numbers. So a trinomial, we know, is three terms, right? Right? And we've been factoring those. We've been factoring, say, x squared. We did this on our warm-up. X squared minus 2x minus 8. That's a trinomial, right? That's a trinomial. It has whole number exponents, and it's got three terms. And we can factor this. We know how to factor this, okay? Now, today we're going to talk about two unique ones, okay? And some of these are super easy. Okay, we've done the hardest factor. We have what we did today with the 3x squared. Oh, what do we have in that warm-up? 3x squared plus a 7x plus a 2. These were the hardest ones. Good news. Today's stuff is really pretty easy. So if we do difference of squares, and they call it difference of squares because you got a perfect square minus. It has to be subtracted. It has to be subtracted. I'm going to highlight that. You got a perfect square, and they call it a perfect square because, as an example, you've got x squared, x times x, and you got 9, which is 3 squared, right? Those are perfect squares, and it just factors into x plus 3, x minus 3. It's that easy. These are super easy. You guys are going to like these, okay? Okay, now, so as an example, let's write down an example. If I had, say, x squared minus 25. These are easy. Everybody can do these. As long as you know what times what makes 25, you're good to go. Now, if you don't know what times what makes 25, you're probably in the wrong class. Would you agree with that? So, x plus 5, x minus 5. Now, why does it have to be plus and minus? Why has it got to be positive, negative? Yeah, Michael's right, because that'll make the negative 25, right? You guys agree with that? Okay. All right, now, the perfect square trinomials will be unique because in the end we can write it as something squared. So let's take a look at an example, okay? We have, slide it up here, we have an x squared plus a 6x plus a 9, right? Ben, stop talking. So if I need to factor this, we already know, if you do your parentheses, right? X and x. What are the multiples of 9? That's easy, 3 and 3, right? And 3 plus 3 makes 6, so it'll be a plus 3 twice. And since you write plus 3, x plus 3, there's two of them, we can write it as x plus 3 quantity squared. Okay? Alright? And the same thing if it's negative, you can do the same thing here. You can write this as an x minus 3, right? Because we know that negative 3 times negative 3 makes a positive 9, right? And then if we add them together, we get the negative 6, but we can rewrite it as a x minus 3 quantity squared, okay? Now here's a little trick that I've kind of said, and sometimes tricks help some kids, but I think you've already learned this. If our sign is negative, then we know the answers are going to have a plus and a minus. You guys agree with that? If our sign is negative, we're going to have a plus and minus. If our sign is plus at the end, they're both going to be whatever this sign is. I'll say that again. If our signs are plus, they're both going to be the same. They're both going to be whatever this is, plus and plus. If this sign is plus, they're both going to be the same. They're going to be whatever this sign is, minus, minus. Do you like that little trick? I'll say it again. The last sign is plus. They'll always be the same signs. same signs, and they'll be whatever this sign happens to be. Minus, minus. Does that help you a little bit? Okay. Always works. Okay. All right. Let's turn the page. Let's do some of these. Okay. Okay. Let's do example 1. Okay. Give it a try. Example 1. Example 1. Let's give it a try. Yep. Not 9 times 9.
9 times 9.
No, not times 9. So what do you guys think? Emma says S plus 7, S minus 7. Thumbs up? Thumbs up, everybody? Thumbs up?
Yeah.
Okay. Okay, here comes your 9, okay?
Yeah, Spencer.
All right, Spencer, number 2. Here comes your 9s, huh? All right. There you go. Go ahead. Give number 2 a try, right? Okay. How about a T plus 9, T minus 9? You guys agree? Thumbs up. This is easy, isn't it? A lot easier than what we did Thursday, Friday. Agree? Okay. Now, number 3 is the same stuff. It's just backwards. That's all. So we'll go 4 plus x, 4 minus x. Okay. It's the same stuff, but we got to put the 4 in the beginning because the 4's got to make the 16 right there. And we'll just go plus x and minus x so we can get a negative x right there, right? Okay. Now, 4 doesn't get any harder. It's just more numbers, that's all. 4 doesn't get any harder. It's just more numbers. So I would go 2g, right? Because that makes my 4g squared. Plus 5 minus 5. Right? You guys agree with that? Is this easy? Okay. And the same thing with 5. Am I going too fast?
Yeah.
Am I going too fast? Yeah. Oh, no, I'm not. Okay. Number 5, give 5 a try and give 6 a try. Okay. Give 5 a try and give 6 a try. Okay. Give 5 a try and give 6 a try. Okay.
I didn't know how to do number 4.
Huh?
I didn't know how to do number 4.
But you got it now, right?
Yeah.
Yeah. And now 5 is the same way, right? 6h, right? Plus 11 minus 11, right?
Oh, 11.
11.
11 is hot. Okay.
There you go. Okay. Give 5 a try, and then give 6 a try, okay? Give 5 a try, give 6 a try, okay? 3h, oops, 6h. What am I talking about? 6h, plus 11, minus 11. Thumbs up on that one? Thumbs up on that one? Spencer, how you doing? Good. Okay. 6. You guys do number 6 yet? You guys do number 6 yet?
No, I don't know what.
9 and 7.
49.
Right?
I thought it was 490.
No, that'd be awful. 9 minus 4k or plus 9. Nope, no, 7. My bad. 9 minus 7k, right? You agree with that? There you go. That's a 7. Bad looking 7. I don't know where the 4 came from. Okay, now, in number 7, so one of the things they do, I want you to see this, is if you didn't have a calculator, okay, one way you could do this is you could rewrite 57 as, you could rewrite this one as a 60, okay, plus 3, okay, there's my 57, right? And 53 could be the same thing as a 50 plus 3, right? Minus 3.
No, 60 minus 3.
Yeah, I do mean that, right? I do mean that, right? Okay.
David, I don't understand.
Okay.
No comprende.
All right.
Comprendo.
Okay, let me keep going with this, okay? That's squared, right? And that's squared, right? You guys got it?
Oh, I
Right?
get that.
Okay.
Yeah, but how is that math?
Huh?
How's that math? How's that work?
Well, how's that math?
Because 50 plus 3 squared is 53 squared.
So we got difference of squares, right? So if we do difference of squares, we'd have 60 minus 3 times 50 plus 3, right? Minus, you ready? We can go at 60 minus 3 times a 50 plus 3, okay? Right? Okay, let me keep going with this, okay? Because you probably will not do this. You probably just use a calculator, agree? But let me keep going with this. So I would get 300. And then this and this would cancel. Minus 9. And then I'd get a, ready, over here, I'd get a 300, right? And then I'd get a minus 9, right? And then 300 minus 300 cancels. And a 9 minus a 9 is just 0.
That's a negative 9 minus 9.
Right, which makes 0.
Negative 9 minus 9 is negative 18.
We'll come back to this because you guys are going to just use a calculator anyway, right? Okay, let's shift the paper over, okay? Let's take a look at 13. 13 is different, okay? Okay, now, Ben, sit down.
I'm helping.
Sit down. So what makes 13 different? 13 is the stuff we've done before, okay? Parentheses, 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 okay? X and X. You with me? X and X. Okay. What times what makes 64? What times what makes 64? Does 8 plus 8 make 16? Yeah. So this is nothing new. Plus 8, right? This is all the same stuff, right? Except for the only difference is the way we can write it. We can rewrite it as x plus 8 quantity squared. Okay, that's the only difference between this, okay? So we've done this kind of factoring before. We have. Okay, the only difference is we can write it like this, okay? Okay, 14, 196. I think it's 14 times 14. I think it is. 14 squared. Yeah. So I can rewrite this as a p plus 14, p plus 14, okay? Now, I know that 14 times 14 makes 196, but 14 plus 14 plus 14 is what? 28, right? So the only difference, so this is the same stuff we've been doing. You guys agree? Exact same stuff. The only difference is we can rewrite this as a p plus 14 quantity squared. Okay, let's do one last one. We'll be done, okay? Actually, two. I'm going to do 15 and 18, okay? Oh, no, I'm going to do a few more. Sorry. My bad. Okay. 15. Okay. All right. 15. R and R, right? What times what makes 169? I think it's 13 and 3. But it's minus 13 minus 13, right? Or R minus 13 squared, right? Sam, can you see that okay? Good. All right, now, let's jump down to 17. I want to look at 17, okay? 17. Okay, watch. Ben, stop talking. 6C, 6C, right? Right? 6C, 6C will make the 36C. And probably 7 and 7, right? Probably plus 7 plus 7. How do we know if we have it right? We check our double smiley, right? How do we know we have it right? We check our double smiley. Okay, we check our double smiley. That's 42C, and that's another 42C, which makes the 84, so I know I'm correct. I do my double check, right? All right, let's move down to number 19, okay? Now, anytime, guys listen to this, anytime you have an x squared, Anytime you have an x squared, Spencer, you gotta listen. Anytime you have an x squared, you always have two answers. I'll say it again. Anytime there's an x squared, there's two answers. So if you look at number 19, there's an equal sign, right? So we've got to have two answers. So a lot of kids will just bring over the 144 and take the squared and get 12. But there's two answers. 12 is only one of the two answers. Okay, I'm going to say it again. A lot of kids will bring over the 144, take the square root and get 12. But there's two answers. So if you factor it, you'll see both answers. So if I factor it, x plus 12, x minus 12, right? You'll get x plus 12 equals 0. And because I'm doing my mini equations, right? Yes, Tim.
But if you square root it, technically square rooting is also
Right. As long as you remember the plus minus. Yep. Yep. You're totally right. I don't want to. I don't want to go there because yes, you're totally correct. But I don't want to. Everybody else go what? Right. And x minus 12 equals 0. Right. So I get my two little mini equations. Oscar, you paying attention? Minus 12, minus 12. First answer, negative 12. Plus 12, plus 12. Second answer is 12. So like Tim said, Tim did say when you take the square root of a number, you know it's a plus and a minus. You're totally correct. But this proves it, doesn't it? It really does show it. Okay, number 20. I'm going to shift over to 20. Here's what you need to do. Please watch. Everybody please watch. Okay, Josiah's watching. When you solve, you need to bring the 49 over. You need to make it equal 0. Okay, you need to make it equal 0, okay? So I'd have a 9y squared minus 49 equals 0, okay? You got to bring it over and make it equal 0, okay? And I got a negative 49 when I brought over and subtracted it, right? Factor 3y plus 7 minus 7. But we're not done. We're not done because we need our mini equations, right? Anytime there's an equal sign, we've got to do our mini equations. So we'd have a 3y plus 7 equals 0 and 3y minus 7 equals 0. Minus 7, minus 7. Divide by 3. One answer is negative 7/3. Plus 7 plus 7. Divide by 3. I get 7/3, okay? I want to do 24 real quick. And then we'll be done. Okay, 24. Shh. Boys, stop talking. Last question. You got to be quiet. And Ben, if I got to talk to Mom and Dad, I've got you on film, don't I?
No, you don't need to do that. I talked to Price.
Yes.
It happens.
Yes. Okay, now, please watch this one. I want to bring over the k squared. When I factor, I like a positive n squared. I like a positive d squared. I like a positive x squared. I do not like negative k squareds. So if I bring it over, it makes it positive. Does that make sense? It's easier to factor. So if I bring it over, I'll have a k squared minus 6/5 k plus 9/25. Now this is fractions, but I can deal with it. I really can. I can deal with this, okay? So when I deal with fractions, I'm going to go k and k, because that'll make my k squared, right? And I'm going to go 3/5. I'm going to go 3/5. See, I'm going to get a 3/5. 3/5 and another 3/5, okay? I know they're both going to be minus and minus. I want you to think about this, okay?
The negative.
Right, so let's think about it. Here's my k squared. You guys see my k squared? Now let's check the double smiley. Remember the double smiley? That would make a, in fact I'll write it down, that would make a negative 3/5 k and another negative 3/5 k. Together they would add up to make a negative 6/5 k, right? Almost done. So it equals 0. I have my mini equations, right? K minus 3/5 equals 0 and another k minus 3/5 equals 0. Now, I get two answers, but it's going to be the same answer twice. I do get two answers. One answer is k equals 3/5 because I add the 3/5. And then the same thing here. So you get two answers, but that's called a double answer. It's called a double answer. The same answer happens twice. Okay, that's all I have. Today's assignment should be pretty easy. A lot of you are way behind. On Friday, I need all of the homework in. Even if you're late and you got to go back and get your assignments in, I want them all in by Friday. Come on, stop recording.
Oh, shoot, they just got that on.
Come on, stop recording.
Stop recording. Thank you. Bye, Mom.